All right, Unit 10, Skill 2. So how can I write recursive or explicit formulas for geometric sequences? So, what does an explicit formula look like for a geometric sequence? Well, the nice part is this one's given to you on the reference sheet, just like it says right here. Come on. All right. And you can kind of get an idea from the recursive formula that you saw last class, is to get the next term, you are going to be multiplying or dividing the rule. Multiplying or dividing the rule. So a geometric sequence is really multiplication. You're either multiplying by a whole number or you're multiplying by a fraction, which is where the division comes in. Okay? But it's a multiplication sequence, so it's just times 2 times 2 times 2 times 2, or times 4 times 4, or times a half times a half times a half times a half. You get the idea. So a sub 1, again, is still going to be a subscript 1, still represents the first term, initial term. Okay, so this is the initial term. In R is what we call the common ratio. You need to get used to seeing that word, common ratio. But you can write the multiplying number as well underneath that. Okay, I'm not going to write that, but you should write the multiplying number. A sub 1 represents initial term. Again, still over here. All right, and again, the idea is just multiply by a number, multiply, 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 multiply. Okay? So, questions 1 through 4, find the explicit formula and the recursive formula. So the explicit formula is usually pretty easy. You just need to know two things. First, what is the starting number? That's really pretty easy to figure out, the first number. And then it says find the common ratio, which is the multiplying number. What number are we multiplying by over and over and over again for the explicit? All right, so the explicit formula, come on, has two parts. We need the initial term, that's 2, times the multiplying number. Well, 2 times 6 is 12, times 6 is 72, times 6 is 432, so I'm guessing it's 6. And we're going to raise that always to the n minus 1. So if I want the first term, I plug in 1. If I want the second term, I plug in 2. If I want the third term, I plug in 3. So just try it with one number real quick in your head. 1 minus 1 is 0. 6 to the 0 works out to be 1. 2 times 1 gives us 2, the value of the first term. Look at that, we have a winner. All right, so the recursive formula. Wow, that's a baddie. Recursive requires that you know the first term, which is, not rocket science. We've already labeled that. A subscript 1 is 2. All right, so we'll get the recursive formula written down. We need our a subscript n. A sub n equals. And what we're doing over and over again, well, we're multiplying by 6. So it's 6 times the previous term. We're not going to write pt there because no one will understand that aside from us. But the previous term to n is the term right before n, so we subtract 1 from n, and that lets us know it's the previous term. All right, let's see if this is going to work now. Nope, it's not going to. All right, I think I got it going now. So, next problem, the explicit formula is going to be a sub n equals the first term, a sub 1, which is negative 1, times r, which is the multiplying number, raised to the n minus 1. So what is the multiplying number? Well, we start off with negative 1, it becomes 3, it becomes negative 9, it becomes 27. So it's definitely multiplying by 3, but it's switching signs every time, so it's going to be a negative 3. And there you have it. To do your recursive formula, okay, same idea. All right, the first term again we know is negative 1. Our a sub n has to be multiplying by, we said it, negative 3 over and over again. So it's negative 3 times the previous term. And again, previous term is denoted with a subscript n minus 1. Question 3, tons of fun. So for question 3, it starts off by giving us the r value and the value of the fifth term. So the multiplying number is 4. All right, so this isn't, a killer question, but it does throw people off. 2, 3, 4, 5. So here are my first 5 terms. A sub 1, a subscript 2, a subscript 3, 4, and 5. And I know the fifth term is 768. So what do I have to do? Well, I could do trial and error and start with 1, right? Put a 1 here and then hit times 4, times 4, times 4, and keep going, right? 1, 4, 16, 64, and then say 4 times 64 is in 768, and that's just ridiculous. It's going to take us forever, so let's not do it that way. All right? Forward. So what I want to do is the opposite of the multiplication. I want to divide. So I'm going to do 768 divided by 4. Type in your calculator, and you get 192. Divide that by 4, and you get 48. Divide that by 4, you get 12. Divide that by 4, and you get 3. Now you can check it. 3 times 4 is 12, times 4 is 48, 48 times 4 is 182, 182 times 4 is 768, and life is good. Okay. Again, it is a multiplying number as you go from left to right. But as you go from right to left, right, that would be a dividing number. So the explicit formula here, let's get going on that. Explicit formula is going to be a subscript n for any value of n. I can find any term I want to, first or the 10th or the 11th or whatever. So the first term is 3. Please show up. That is weird that it didn't. Let's try again. 3 times the multiplying number, which they already told us that. It's right there, 4, raised to the n minus 1. And we're good to go. The recursive formula. So the recursive formula starts off with the first term, and we now know the first term since we wrote it out. That's 3. The recursive formula requires that you do something to the previous term. So what were we doing over and over to the previous term? Yep, it was that simple. We multiplied it by 4. So it's 4 times the previous term. And again, the previous term to a subscript n is a subscript n minus 1. That's it. Let's move on to some more challenging questions, because they do unfortunately get quite a bit harder. All right, so what do we got here? Find the explicit formula and the recursive formula when we're given a whole bunch of not fun stuff. So it's weird that they gave us the third term and the sixth term, but we can figure this one out. So start out by writing the first 5 terms. So 6 terms, 1, 2, 3, 4, 5, 6. So first term, second term, third term, fourth term, fifth term, and sixth term. We know that this bad boy is 27, and that is 729. So you try a couple of numbers in here, and it's going to work out. So you try 2. 27 times 2 is 54. 54 times 2, 108 times 2, not going to work. So then you try multiplying by 3. And when you multiply by 3, you first get 81. And then multiply by 3 again, you get 243. And conveniently, when you multiply by 3 again, you get 729. Life is good. All right, so now we know that the multiplying number is 3, but we got to go backwards now. Okay? So divide again, and you get 9, and then 3. Another trick you can do is take the 2 numbers that you have, okay, which was 729 divided by the 27. All right, divide them. This just conveniently works out to be 27. You take that number, and you had to go 1, 2, 3 powers. So we find the third root of whatever that number was right here, and that gives us our multiplying number as well. Okay. Usually trial and error is going to work, but if you want to memorize that, you totally can. So if I had to go 4 places, I would be the fourth root. If I had to go, again, 1, 2, 3 places, it's third root. 1, 2, 3 in another place, that'd be fourth root, and so on and so forth. All right. So the explicit formula. Since we have our starting number, we're good to go. A sub n is the first term, 3 times the multiplying number, which in this case is also 3, to the n minus 1. The recursive is going to be a sub 1. Come on, get back there. A subscript 1 is going to be 3. And it's, what are we doing to the previous term? Well, we multiplied the previous term by 3, so it's 3 times the previous term, which is going to be our a sub n minus 1. Okay, given the following recursive formula, find the 15th term. So you can choose crazy here. I mean, you really can. You can choose crazy on a problem like this, and you can multiply times 2 15 times. So negative 2.5 times 2, and then that times 2 times 2 times 2 times 2 times 2 times 2. You know, and you might get it right. You hopefully won't mess up, and you can be okay. And if that happens, sure. But on the Regents, I'm betting they're going to ask for like the 150th term. So you're going to sit there for like a half an hour pushing buttons, and then you won't know if you actually did the 150th or the 149th, and then you might get it wrong, and that'd be bad. So I would recommend doing this the right way, but you totally can cheat this question if need be. Okay. So what I would do, if given the recursive formula, is find the explicit formula. And the reason I would do that is this explicit formula, I can plug in any number I want. If I want the 15th term of this, I can plug in 15 here, put a 15 here, type in the calculator, and be done. For this recursive formula, I need to know the 14th term. Well, to get the 15th, and to get the 14th term, I need the 13th, and the 13th, I need the 12th, and you get the idea. It's going to take forever. So, much faster to write the explicit formula first, and it's actually pretty basic. It's not going to kill you. So the explicit formula is a sub n equals a sub 1, the first term. Go figure. They gave us, the first term, times the common ratio, which is the multiplying number. Well, hey, looky, there's the multiplying number right there. So times 2 to the n minus 1. And there we have it. So from there, when I want the 15th term, which is what the question is asking for, I plug in 15. So a subscript 15 is the value of the 15th term when 15 is plugged in place of the n. So I raise to the power 14, then I multiply by negative 2.5. And remember, I know exponent rules are things that people are struggling with a little bit this year. 2 to the power we do first, and then we multiply by negative 2.5. Do not multiply in and then do the exponent. Anyways, type in the calculator. You get yourself an answer for a subscript 15, which is the 15th term, is equal to negative 4,960. Okay. A great way to check it is to totally use your calculator with what I taught you last class. The problem with doing that is your solution is there's no work you can show. So remember, you go to your calculator, you type in u sub 1, and you go to the graph, and type in u sub 1 and u sub 1 sub n minus 1 and all that good fun jazz. That's really not a whole lot of fun, but it's quick in the calculator. You can do that. The problem is you're not going to be able to show any work. So this is a way that you can show some work, get full credit on a short answer Regents question. Question 6. A population of 800 beetles is growing each year at a rate of 5% every year. Or we could just say it's growing at a rate of 5% per year. But yeah, sure, that's a great way of wording it. Anyways, which formula would model the situation? All right, so we need to know which formula is modeling it. Well, if it's growing at a rate of 5%, the rate isn't 5%. Remember, the rate that we're talking about has to be above or below 1. So how much above 1 are we? We're going to be at 1.05. So 1 plus the 0.05, since it's growing, gives me my 1.05 is my R. That is the growth rate. And then my starting amount, my initial amount, must be 800. So for our explicit formula, if it is that, I would have a sub n, or in this case, it looks like they're using p. P of t, it should be. That's interesting that it's written wrong. But it should be p of t equals 800 times 1.05 to the t minus 1. But that isn't an answer, is it? So they must have gone with the recursive formula. Figures I chose wrong. So the recursive formula starts out with the first term, and that would be p sub 1, because they're not using a. That's obnoxious, but p sub 1 is going to be 800. And again, what am I multiplying by the previous term every single time? Well, so that's p sub t in this case, not n, equals the 1.05 times p sub t minus 1, which is answer choice 2. 1.05 times p subscript t minus 1. That is obnoxious when they're not using the same subscript. Just like the calculator uses u, they don't have to use a. That's that. Make sure you do your note, or write your summary and get your practice done. Thank you.